Amisha, can you hear me? Amisha, can you hear me?
Good morning, ma'am.
Good morning. Can you hear me?
Yes, ma'am.
Okay, thank you. Today we are going to start the next chapter, that is thermodynamics. Thermo means heat. Dynamics means movement. So this deals with energy transformation. Study of energy transformation in macroscopic system. Macro means bada. Energy transformation, study of energy transformation in macroscopic system. For example, heat absorbed or heat liberated. How much heat is absorbed? How much heat is liberated? That we learn in this chapter. In microscopic systems, we learn reaction mechanisms. In macroscopic systems, we learn energy transformation. In microscopic system, that is very small things. That is, we learn mechanism, reaction mechanism. But in macroscopic systems, we learn energy transformation. For example, how much heat is absorbed, how much heat is released. Before entering to this chapter, we have to, before going for this energy transformation, we have to learn some terms. Some terms here to learn, right? Those terms, some terms. Number one, system. Number one, system. System. Write down. A system refers to that part of universe. A system refers to that part of universe under investigation or observation. Under investigation or observation. If you're learning a reaction in a test tube, so this reaction mixture is the system. Reaction mixture is the system, and rest everything around this system is called surrounding. Surrounding, and the system and surroundings are separated by this boundary. This boundary. So system, anything which is under observation or in investigation, the part of the universe which is under observation or investigation, that is the reaction mixture, that is the system. And outside, rest part of the universe other than the system is called surrounding. And the system and surroundings are separated by boundary. This boundary may be a conducting boundary, means heat produced in the reaction mixture can be transferred to the surroundings, or it may be a non-conducting boundary, very well packed, that is like a thermos. From inside the heat cannot come outside, that is called an adiabatic wall. Adiabatic wall. Adiabatic wall. There, heat from inside cannot go to outside, from outside it cannot enter inside. Such a wall, such a boundary is called adiabatic wall or adiabatic boundary. If the boundary is a conducting one. For example, a steel glass. Steel glass. Some reaction we have done inside the steel glass and the heat produced immediately goes to the surroundings. So such a wall or such a boundary is called isothermal wall. Isothermal. Isothermal wall. So through this glass, steel glass, the heat will be moving to the surroundings and the temperature will always be same, isothermal, same temperature. If it is an adiabatic wall, adiabatic boundary, the heat produced inside will remain there only. It cannot escape to the surrounding. So the temperature will be increasing inside this reaction mixture. So two types of walls, adiabatic wall where no heat is transferred between or exchanged between system and the surrounding. Isothermal wall where heat is always transferred between system and the surroundings. System plus surrounding is the universe. System plus surrounding is the universe. Okay, next heading, surrounding. Surrounding. Surroundings include everything in the universe other than the system. Everything in the universe other than the system. Now, what is a boundary? Boundary. The real or imaginary wall, that separates system from surrounding. That separate system from surrounding is called boundary. It may be a conducting wall, means isothermal wall, or it may be an adiabatic wall, that is non-conducting wall. So system plus surrounding is the universe. The real or imaginary wall, that is called boundary. The boundary can be adiabatic, boundary can be isothermal. The boundary can be non-conducting, the boundary can be conducting. Next, types of systems. Types of systems. There are three types of system. That is open system, closed system, isolated system. Number one, open system, closed system, and isolated system. Isolated system. Open system. You consider hot water taken in a beaker, in an open beaker. Hot water taken in a beaker. Hot water is taken and it is open. So some vapor will go out and the heat energy is also going out. So matter and energy both are getting transferred with the surroundings. So in an open system, matter as well as energy both are getting exchanged between the system and the surroundings. What about a closed system? A closed system I have taken hot water in this closed system. Of course, after some time, water becomes cold. Water becomes cold, that means energy got exchanged between system and the surrounding. But vapor is not escaping. It is going, touching the lid and coming back into the system only. So only heat energy got exchanged. Only energy got exchanged, not the matter. Such systems are called closed system. Now, what about isolated system? Isolated system means hot water taken in a thermoflask. Hot water taken in a thermoflask. thermoflask, I have taken hot water. Neither matter nor heat energy will be exchanged with the system and the surroundings. So, there are three types of system: open system, closed system, and isolated system. In open system, write down, in open system, there is exchange of energy and matter. There is exchange of energy and matter between the system and the surroundings. Example, hot water taken in an open beaker. Hot water taken in an open beaker. Hot water taken in an open beaker. Closed system. In a closed system, there is no exchange of matter, but exchange of energy. In a closed system, there is no exchange of matter, but exchange of energy between the system and the surroundings is possible. For system, you write always sys. For surroundings, you write sir. S-U-R-R, sir. Because in this chapter, many times we will be dealing with system and surroundings. So every time, don't write this full system. For system, S-Y-S, surroundings, S-U-R-R. Example here for closed system, hot water taken in a closed vessel. Hot water taken in a closed vessel. Now in isolated system, there is no exchange of energy or matter. There is, you can write, in isolated system, there is no exchange of energy or matter between sys and sir, between system and surroundings. Example, hot water taken in a thermoflask. Hot water taken in a thermoflask. Next heading, state of a system. State of a system. System means anything that is under investigation or observation. Now what is meant by state of a system? State of a system. We call them as state variable. The variables by which you can define a system. For example, I can define a system by telling its volume, pressure, temperature. Suppose I have taken gas in a gas cylinder, or looking at the gas cylinder which contains gas in my house, I am telling that the substance what is present inside this gas cylinder is a system. I can define that system. How is that system? What are the things in that system? Or how can I define that system? I can define that system. This system means, this gas in the gas cylinder means it has got a pressure, it has got a volume, it has got a temperature. I can state the system, okay, this is the state, this is the state. I can tell the system by indicating its pressure, its temperature, its volume. So I am defining that system by indicating its so and so things. Means I am stating these pressure, temperature and volume. I am defining that system. This can be varied. These P, V and T, they are called state variables. The variables by which I define that system, I mention that system, those variables are called state variables. And the state variable's value depends only on the initial and final stage. It does not depend upon how the change has been taken place. So what is a state variable? A variable whose values depend on or depend only on the initial and final stage. Pardon, what is a state variable? What is a state variable? State variable means that state variable means that state variables state variable means that their values depend only on the state of the system. Their values depend only on the state of the system and not on how it is reached and not on how it is reached. Or their values depend only on the initial and final stage. Or their values depend only on the initial and final stage. So I told you P is a state variable, V is a state variable, T is a state variable. By these variables you can mention a system, you can define a system, and their values depend only on the initial value and final value. Suppose volume. Today in a pond, there was some water. Volume of water is only 2000 liters. In that pond, the volume of the water today is only 2000 liters. Tomorrow, I am going to that pond. I see the volume of water in that pond is 10,000 liters. 10,000 liters. One day before, 2000 liters. Next day, 10,000 liters. How this water came into that pond, extra water? I don't know. Maybe due to rain or by using a tube well, somebody pumped water into that pond. By somehow, volume of the water is now 10,000 liters. So volume does not depend upon whether the pond is filled with rainwater, or the pond is filled with the tube well, or the pond is filled by both. In any way they can fill the water, but the volume of that water depends only on the initial and final stage. Previously it was 2000, now it is 10,000. Volume of the water does not depend upon how it is getting filled, by rain, by tube well, or by both. Volume now 10,000. So volume is a state variable whose value depends only on the initial and final stage. How much volume of water is added? That is 8,000. That depends only on the initial and final, 2000 and 10,000. That does not depend, this 8,000 does not depend upon this change in volume, does not depend upon the way by which this pond is getting filled. So volume is a state variable, means whose value depends only on the initial and final stage. It does not depend upon how the change is being reached. Next term we are going to learn is internal energy. That is another term you have to learn, internal energy. Internal energy. What is meant by internal energy? Internal energy is the energy of a substance, means that accounts for all types of energy the system has. It may be potential energy. It is a sum total of all types of energies: potential energy, kinetic energy, heat energy, light energy, sound energy, vibrational energy, rotational energy. So all types of energies, the sum of all types of energy of a system is called its internal energy. It is denoted by U. In some textbooks it is denoted by E. So internal energy, write down what is internal energy. It is a sum total of, it is a sum total of all types of energies of a system. All types of energies of a system. In bracket you write chemical energy, electrical energy, mechanical energy, kinetic energy, potential energy, sound energy. Means it comprises all types of energy and we call it as internal energy, U. Change in internal energy is denoted by delta U. Change in internal energy, you can change the energy, its internal energy you can change, that is denoted by delta. Any change you can show it by delta U. Now, internal energy can be changed by different methods. For you, write down. Internal energy can be changed by number one. Internal energy can be changed by number one. Work is done on the system or work is done by the system. Work is done on the system or work is done by the system. What is meant by work is done on the system? Suppose cycle pump. वो पुराना cycle pump. You are pressing. A gas is there inside that column, that is air. Air is there inside that column, that is wash and the washer and that bottom plate. There is a column. Air is there. That is the system. You are pressing that air, means work is done on the system. Work is done on the system. When you press, what will happen after some time? You feel that it is heated up. By chance, if that material body, that cycle tube's body touches on your leg, you feel heated up. You feel that hotness. Sometimes it burns also. So energy got changed. Internal energy of that air got changed. Work is done on the system. Work is done on the system. Number two, work is done by the system. When a gas expands, see the piston you are using the piston, you are pushing that air inside that cycle tube. Suppose that piston is a smooth moving piston, frictionless piston, and you are heating that gas, the piston will be moving forward. When you heat the gas expands and it pushes the piston outside. Work is done by the system. W, work is done by the system. So internal energy can be changed. Number one, work is done on the system, which is taken as positive, and work is done by the system, which is taken as negative. Number two, internal energy can be changed by how? Heat passes into the system or out of the system. Heat passes into the system or heat is moving out of the system. Heat passes into the system is taken as positive, into, and out of the system is taken as negative. Heat absorbed by the system, that is taken as positive. Heat released from the system is taken as negative. So first one, work is done on the system, work is done by the system. Internal energy can be changed. Second, heat passes into the system or heat passes out of the system. That is, internal energy is changed. Number 3, matter enters, matter, M-A-T-T-E-R, matter enters or leaves the system. Matter enters or leaves the system. So first and second point will be discussed in this chapter. How this internal energy is changed, delta U, how you can change the internal energy. How can you get a delta U? So first one, work is done on the system, work is done by the system. You take water in a mixie, and you churn it, that water. After churning for some time, you feel that the water got heated up. Water got heated up. Means you are doing the mechanical, you are giving the mechanical energy. When you give the mechanical energy, suppose 1 kilojoules of energy you give. Before churning the water, let the temperature be TA, and after churning for some time, water got heated up. Now the temperature of water is TB. Change in, of course, internal energy got changed. Water ka temperature increased, energy increased. So change in internal energy can be given by, it is a measure of what, TB minus TA. TB minus TA will give you some idea of the change in internal energy. We have given 1 kilojoules of energy, mechanical energy. We took some water, we gave 1 kilojoules of mechanical energy, and before giving energy, temperature of water was TA. After giving this mechanical energy, the temperature of that water is TB. TB minus TA will give you some measure of that change in internal energy. Now, this 1 kilojoules of energy I can give by some other method. For example, I am putting an immersion rod. In olden days, we used to heat water. Before these geysers, we used to heat water by putting the immersion rod. You know, immersion rod, it looks like this. Like this immersion rod. Using this immersion rod, suppose I am giving 1 kilojoules of energy, heat energy. First I gave mechanical energy. Now I am giving 1 kilojoules of heat energy only to that water. The temperature before was TA. Temperature of that water in the bucket was TA. And when I put 1 kilojoules of energy, I noticed that the temperature is, when I gave 1 kilojoules of energy, I noticed that the temperature is TB. So whatever may be the method of giving this energy, change in internal energy, that remains the same. Delta U, that remains the same. That means change in internal energy is a state property. It does not depend upon how the change is carried out, whether it is through the mixie or through the immersion rod. When 1 kilojoules of energy is given, automatically the temperature comes as TB. That means change in internal energy, delta U, is a state function. State function means that or state variable. State function. State variables are also called state functions. It is a state function, that means its value depends only on the initial and final state and not on how the change is being reached, whether through the mechanical energy, that is in the mixie, or through the immersion rod. Okay, thank you. So delta U is equal to, that is a heat given, heat exchange, that is called Q. Heat absorbed, that is plus Q. Heat into the system, that is plus Q. Now we have given only heat. Thank you.